Hello, welcome again. We are solving some questions of theory machine. The topic is vibration. Question number 91 from gate 2020 ME-01 is a rigid massless rod of length L is connected to a disc bracket pulley of mass M and radius R is equal to L by 4 through a frictionless revolute joint. The other end of that rod is attached to a ball through a frictionless hinge. A spring of stiffness 2K is attached to the rod at its midspan. An inextensible rope passes over half the disc periphery and is securely tied to a spring of stiffness K at point C as shown in the figure. There is no slip between rope and pulley. The system is in static equilibrium in the configuration shown in the figure and the rope is always taut. So this is the figure given or the system shown. So this is your spring of stiffness 2K and this is spring of stiffness K and this is L by 4, R radius is R L by 4, this point is C, this point is B, this point is A. This is your massless rod and this is your L by 2 and this is L by 2. Okay, so and this is your inextensible rod. Neglecting the influence of gravity, the natural frequency of the system for small amplitude vibration is option A root 3 by 2 root K by M, option B 3 by root 2 root K by M, option C root 3 root K by M, option D root K by M. Okay, so this is the system and now if we displace the system about A by an angle theta or displace the rod by an angle theta, then the compression of this spring will be your L by 2 into theta because this is your L by 2. Okay. And the expansion of this spring is your L plus L by 4 theta. Okay. And the spring force will be in upward direction and here it will also be in upward direction because it is compression and it is expansion. Okay. So as this spring is tied to this string, so it will exert the same force or same tension in the string as that of spring force. Okay, so the spring force, so the tension will be a K L plus L by 4 theta. Okay, so now if we want to convert the that dynamic problem into static problem, we will introduce inertia torque, that is I theta because this is your massless rod and disk is having some mass, so we will have moment of inertia. So and the system is rotated about point A, so I is moment of inertia of the disk about that point A. Okay, and that I theta double dot is your inertia torque, theta double dot is angular acceleration. Okay, so these are the forces and torque acting on the system. And now we take moment about A, then moment about A will be your I theta double dot or I is your ml scale because the disk is having mass m and its mass is concentrated at this point. Okay, and we have to take moment of inertia about this point. So that distance is L, so it is ml scale. Okay, so disk is not rotating, it is just getting displaced, so it will behave like a mass. Okay, so mass is rotating about this point, so it will its moment of inertia will be ml scale and it will be ml square theta w. Okay, plus now this is the this itself will be moment. So now its moment about this point will be clockwise and its moment will about this point will be counterclockwise and its moment about this point will be counterclockwise and its moment about it will also be counterclockwise. So all these will get added. Okay, now if we take this moment, the force of this moment, then it will be 2k into L by 2 into theta into L by 2. Okay, and now we take moment of this force about this point, then it will be k into L plus L by 4 into theta into L plus L by 4, that distance. Okay, and now if we take moment of this force, then this distance is your L by 2 plus L by 4. Okay, so rest of the force is same. Okay, that is same. Okay, so now if we solve it, then we get equation ml square theta double dot plus 48 by 16 kl square theta. or we can say it is ml square theta double dot plus 3kl square theta equal to 0, or omega comes out as root 3kl square by ml square or root 3k by m. Option C is the right answer. For calculating omega, we will take the coefficient of theta double dot and coefficient of theta, and coefficient of theta is here and coefficient of theta is here. Answer is option